Welcome back, guys. In this video, as promised, we are now looking at another case of relationships of angles within a cyclic quad. Okay, remember in the previous video we spoke about opposite angles. Now we are going to discuss angles in the same segment. Let me just remind you of what we meant about angles in the same segment. Quickly, we had spoken and said, if I was to draw a chord here called BD, then this portion here is the small segment, and this portion here, which is this one here, is the bigger segment. So what is happening here, you've got to note and realize that angle C and A are actually in the same segment. But of course, we've got to check which chord are they on. You can see clearly angle C. If you are to trace, let me just remove this markings. If you are to trace with me here, the chord that subtends angle C and angle A, you'll see it's called BD. And of course, it will not always be a chord. Sometimes you will not have a chord, but you will have an arc. And in this case, you must know this, guys. This is something that should be embedded in you. BD, without a say, is an arc. In fact, whenever you've got 2 points on a circle, that constitutes 2 arcs already. Of course, the 2 arcs might have the same letters, but you may name them differently. Of course, okay, I hope you get what I'm saying there. For example, let's just assume B and C are the only points on the circle. Then you actually have arc BC or arc CB. One arc is bigger than the other in that sense. So you must have that conceptual understanding. As a matter of fact, I'm going to focus on the arc right now. So let's look at arc BD. And you see that if you trace the arms of angle A, you see that they are hanging right on chord BD. And the same thing happens if you trace the arms of angle C here. You can see they are hanging on chord BD. And we call this angles subtended by the same arc, but correctly speaking, or commonly as it is said, they are angles in the same segment. And guess what? Again, I just drew these angles and measured them. It happens that these angles are equal. Check, A is 37.37, C is also 37.37. Of course, the units are degrees. So you can see they are equal. Very, very important. Guess what, guys? The same thing happens with angle B and D down here. Angle B, as you can see, it is subtended by arc AC or arc CA, if you're reading from there to there. And the same thing with angle D. And not surprisingly, they are equal. You've got to always see this. And of course, here, if we were to join, now, if I was to, let me actually do that. If I'm to join now, these lines here, if I'm to join AC and I'm to join BD, you can see I have a cyclic quad. You can see that I've got a cyclic quad. Now, what's important in the cyclic quad is to actually note, and this is very important, guys. Oh, I think you should note this one. Very, very critical for me at this point that I point this one for you. Notice something. I can refer to this as angle C1 and that as C2. I can refer to this as A1 and I can refer to that as A2. I can refer to this as B1, that as B2, D1, D2. What is quite interesting then, from what I just discussed with you about angles subtended by the same arc, notice if we look at angle C2, now let me just quickly take a different color here. Angle C2 is going to be this angle here. It is subtended by arc AD or chord AD, if you may like. Now, what is the other angle that is subtended by the same chord or the same arc? Well, you can see that angle B2 here is also subtended by the same arc or the same chord AD. Therefore, we can't help but conclude that actually angle C2 should be angle B2. And they are subtended by the same arc or the same chord, or you can simply say, well, these are angles in the same segment. Now, let me quickly write down what we already found previously from measuring. We can see that C1 is A2. This one we have previously discussed. You can see also that B1, angle B1 is equal to angle D1. This came as a result of me introducing what? The chords, okay, and making this cyclic one. Now, C2 is B2. I'd like for you to pause before I continue and find out what other angles are equal. Pause right now. I hope you did pause. Now, let's come to the conclusion of the whole matter. Let's quickly conclude. Let's find, my bad, I canceled my chord there. Let's quickly now find the other angles that are equal. So, of course, we are going to just use the same principle that we have used. I'm going to look at A1 here. If you look at angle A1, it is subtended by chord BC. But obviously, another angle subtended by chord BC should actually be angle D2. Actually, those are the only remaining angles. So we can see now that, well, angle D2 is actually equal to angle A1 because they are in the same segment, or they are subtended by the same arc, or you can say by the, they are subtended by the same chord. Very, very critical discussion here, guys, that we are having. Now, of course, as usual, I'm gonna end this by having some fun with this quadrilateral, but be mindful of the fact that actually my chords, because I had not drawn them on GeoGebra, they might vary. So I'm quickly going to draw them on GeoGebra, and then we have the nice simulation or fun, if you may say. So I've gone ahead to just complete my drawing, and you can see I've colored now the angles that are equal of the same color so that you guys make sense of this, because I have now explained the concept why they are equal. Now let's have some fun as usual and see how we still get angles in the same segment even when we adjust positions accordingly. And believe you me, you will get something like this in the exam. You can get something like that in the exam. You can get something big as that in the exam. What should be the bottom line here, what you need to really understand and get is that in this case, these angles remain equal. The angles in green are still equal. You can see the measurements there. You can see also the angles in purple are still equal. Those are your angles in the same segment, guys. Look at how they are positioned differently, but they still maintain the same measurement. Look at this, guys, still the same thing. You can see angles in purple still equal. Those in green there still absolutely on point. You can see, even if I have moved, look how differently I've actually rotated somehow the quadrilateral around the circle. Still, the relationship holds, guys. Doesn't matter at what point I get. Look, I can even make things and make the angles this close. And I've seen questions which have a diagram like this, and students could not figure out the relationship. Let me leave it here, guys. I hope you have had some fun. Cheers.